All right, today we are venturing right into the heart of the atomic nucleus. We're on the hunt for a ghost, but it's not the kind you're thinking of. This is a geometric ghost, and if we can catch it, it might just force us to remap our entire understanding of reality itself. So let's just jump right into the core problem, the central paradox of what's called alpha decay. I want you to picture a prison, a fortress. The walls are so high, so strong that escape is a literal physical impossibility. Now imagine you're watching that prison and a prisoner just appears on the outside. That is exactly what physicists see happening inside atomic nuclei every single day.
Look at this. On the left, you've got classical physics, the rule book we all learn. You have an alpha particle with only 4 mega-electron volts of energy. It's stuck inside the nucleus, trapped by an energy barrier that's 25 MeV high. The rule is simple. If you don't have enough energy to climb the wall, you don't get out. Period. You are trapped forever. But then you look at the right side, and that's reality. The particle does get out. Decay happens. So the lesson here isn't that our classical map is wrong, it's that it's just nowhere near the full picture.
To solve this puzzle, 20th century physics had to draw a totally new map. This one wasn't based on certainty, but on something much weirder, probability.
So how is this possible? The new map's big idea is called quantum tunneling. It says, well, the particle isn't just a little ball, it's also a wave. And you know how you can kind of hear a muffled sound through a solid wall? That sound wave is bleeding through. In the same way, the particle's wave function has a little tail that extends through that impossible energy barrier. This gives it a tiny, but crucially not zero probability of just popping into existence on the other side. It's basically a game of quantum chance. But here's the catch. This map, as successful as it's been, has some really big problems. The standard picture asks you to imagine this little alpha particle rattling around its nuclear cage, hitting the wall 1,000 billion times every single second, just waiting for that 1 in a trillion lucky roll of the dice to tunnel out. But as physicists Crowley and Day point out, a complex particle like an alpha just wouldn't survive that. It would be ripped apart. The map is useful, for sure, but it feels flawed.
So this gets you thinking. What if the issue isn't a flaw in the map? What if the problem is that we're looking at a map in the first place? What if instead we could look at the actual territory itself?
And this brings us to a mind-bending framework, something called timeless counter space and shadow gravity, or TCGS for short. It suggests that the fundamental reality, what we're calling the territory, is a static, four-dimensional geometric object. I want you to try and picture this. It's not empty space with little bits of matter moving through it. It's a single, complete, shimmering crystal of pure geometry. Nothing in this territory is truly moving or changing. It all exists right now as one thing.
So, where are we in all this? Well, we are the map. The entire three-dimensional universe we experience is just a shadow, a slice, of that much larger four-dimensional reality. Think about a mountain. The 4D territory is the whole mountain in all its rugged glory. What we see, what we call our universe, is just a single contour line on a topographic map of that mountain.
Okay, but if the whole thing just exists, static and unchanging, where does time come from? The feeling of things happening one after another. In this view, time is an illusion, an artifact of how we observe the territory. Imagine a kind of scanner. Physicists call the process foliation that's moving across the static 4D object. It reveals one 3D slice after another, like you're flipping through the pages of a book. Our perception of time passing is just our brain experiencing the scan moving from page to page. Time is just the page number, not a fundamental part of the story written on those pages.
So, how does this completely new perspective, this 4D territory, solve our impossible escape paradox? Well, it flips the whole problem on its head. If geometry is all that truly exists, then geometry must be destiny. In TCGS, quantum tunneling isn't a game of probability at all. It's a journey. If you could zoom into the 4D geometry of the nucleus, with a sensor of unimaginable power, you would see something our 3D map can't even show. You'd see a topological handle. Think of it as a stable, wormhole-like bridge made of pure geometry, a structure that connects the inside of the nucleus to the outside by arching through that hidden fourth dimension. The escape route was always there, literally built into the fabric of reality.
Now, any new theory of decay has to face the music. It has to explain the Geiger-Newton law. This is not a suggestion, it's an ironclad experimental fact. It says that particles with just a little bit more energy escape exponentially faster. We're talking a tiny change in energy can mean the difference between a half-life of microseconds and a half-life of billions of years. How on earth can a geometric theory explain that kind of insane sensitivity?
Well, TCGS offers just a beautiful solution. A low-energy particle corresponds to a path that has to take the long way around. It's forced to follow a very long, thin, incredibly winding path along that 4D handle. If we could see this, it would look like a faint, shimmering thread of light, almost frayed, as it meanders through this complex crystalline structure. The half-life we measure isn't a waiting time. It's a direct measurement of this enormous geometric distance the particle's path has to trace in the 4D territory.
But a particle with higher energy? That's different. That particle gets access to a kind of geometric express lane. It can take a shortcut, a much shorter, wider, more direct route through the handle. Visually, this path would be a thick, intensely bright beam of light, a superhighway cutting cleanly and directly right through the 4D structure. A shorter geometric path in the territory projects into our 3D shadow as a shorter half-life. Suddenly, the Geiger-Nuttendal law isn't a probabilistic miracle anymore. It's just a roadmap of the 4D highway system.
This new perspective forces us to get really rigorous and make a crucial distinction. What is a real fundamental feature of the 4D territory, and what's just an illusion, an artifact of our 3D map?
And this table here really sorts the wheat from the chaff. On one hand, you have slice and variance. These are the real deal. They are unchangeable features of the 4D landscape itself, like how steep a mountain is. The Geiger-Nuttendal slope is one of these real features. But on the other hand, you have gauge artifacts. These aren't fundamental properties of reality, they're byproducts of how we measure reality. They're artifacts of our scan. Half-life is the perfect example. It's a measurement that depends entirely on the speed of our foliation scanner. Change the scan speed, and you change the measured half-life without changing the underlying 4D geometry one bit.
Okay, but this leads us to the biggest, most obvious question of all. If this 4D territory is a fixed, deterministic, geometric object, why on Earth do we experience radioactive decay as a fundamentally random, probabilistic event? The answer that TCGS proposes is subtle, but it's really powerful. The randomness isn't in the territory, it's in the scan. Imagine our 3D slice, our reality, moving through that 4D space. Now, the exit of that geometric handle we talked about is infinitesimally small. Our 3D slice is constantly and randomly changing its orientation as it moves. So, whether our slice happens to intersect with that tiny exit at any given moment is essentially a random event, like randomly throwing a dart. It's this random sampling of a totally deterministic object that creates the appearance of probability in our shadow world. And the math works. A constant probability of hitting that handle perfectly generates the exponential decay law we actually see. A deterministic territory plus random sampling gives you a probabilistic shadow.
So let's just zoom out for a second and take in the grand view that this new map of reality is showing us.
So here's the bottom line. Alpha decay is a matter of geometry, not of chance. That quantum tunnel is a real, physical shortcut in a higher dimension. Half-life is a measure of geometric distance, not a duration of time. Our entire universe may just be a projection of a greater, static 4D reality. And this leads to the biggest leap of all. This framework suggests that other huge mysteries, things like dark matter, might not be separate problems. They too could just be projection artifacts, shadows cast on our 3D cave wall by a reality we can't directly see.
And that leaves us with a final, pretty profound question to chew on. This framework recasts time as an illusion of our perception and quantum chance as an artifact of our observation. If some of the most fundamental pillars of our reality turn out to be just shadows, what else is? What other parts of our universe are just contour lines on a map of a territory we are only just beginning to chart?